Okay, guys, this is where we left off yesterday. We were solving and evaluating some logarithms that you can do without a calculator. So when you're trying to evaluate something, you don't know what it is. Let's just say that it is x, okay? This means that the log base 9 of 81 is x over 7. Now convert that to an exponential equation. This means that 9 to the x over 7 is equal to 81. Well, we solved this particular kind of equation last semester. You can write this as 9 to the x over 7 equal 9 squared. That means that x over 7 is equal to 2, or x is equal to 14 in that case. Okay, so solving logarithms. The things that we talked about in this unit, this first lesson, is you got to be very comfortable going back and forth between exponential form and log form. The key is in exponential, you know where the exponent is. You've known that since middle school. In a log form, that exponent gets moved off all the way on the other side of the equal sign all by itself, okay? The other thing, when you see log b of b to the x, that answer is x, okay? B to the log b of x, that is x. These are inverse functions of each other. When you see a log with no base, that log is 10. When you see natural log, that means log base e, okay? And you should be able to evaluate expressions based on that. So let's just take a look real quick at the review, some of the classwork that led into the homework that you did last night, just to make sure you're good with it. To evaluate this without a calculator, it's equal to x. Convert it to exponential. 6 to the x equal 36. X is equal to 2. This is equal to x. Convert it to exponential. 2 to the x equal 1/2. That means that 2 to the x equals 2 to the negative 1. That's what 1/2 is. X is equal to negative 1. 2 log 12 of 1. What is it? It's going to be x because I don't know what it is. But this means that the log base 12 of 1 is equal to x over 2, which means that 12 to the x over 2 is 1. The only thing I can raise 12 to and get a 1 is 0. So x is equal to 0 here. 4 plus log 100. Okay, so I know what 4 is. Let's just figure out what log 100 is. Log 100 is equal to x. Okay, this means that the log base 10 of 100 equals x. So 10 to the x equal 100, or x is equal to 2. So this is just 4 plus 2, which is 6. Going back and forth between log and exponential form. Convert these to exponential form. The base is 5. The exponent is 7. In this case, the base is 10. The exponent is x plus 1, equal 9. In this case, the base is 3. The exponent is b, equal 11. In this case, the base is e. The exponent is 2x minus 3, equal 2x plus 3. Write these in logarithm form. Log base 5, the exponent is x. Here, the base is e, so log base e. The exponent is 2x. The other way of writing this is natural log of 9y equal 2x. In this case, the base is q. Log base q. The exponent is negative 3. 1 over 5x. In this case, the base is 9. The exponent is 15. So the log base 9 of x squared minus 1 equal 15. And that leads you into the homework. Now today what we need to talk about are some properties of logarithms, mainly expanding logarithm expressions, okay? So here are some rules that we're going to need. The product property. When you are taking the logarithm of a product, remember, logarithms solve for the exponents. How do you multiply with exponents? You add the exponent. So the log of a product, log of m times n, is the log of m plus the log of n. So it's the log of the sum, the individual logs, okay? With quotients, when you have exponents, when you're dividing like x to the 7th over x to the 5th, you subtract your exponents. So the log of m over n is the log of m minus the log of n. And then the power property. When you have the log base b of m to the nth power, you can bring that exponent out front. That's n times the log b of m. So let's just work with these properties. You're going to need to know these and how to apply these, okay? Use the product property to expand. So this is, according to the product property, the log, and what did I use? X's and Y, let me be consistent, m's and n's. So the log base b of mn is the log base b of m plus the log base b of n. Okay, so this just means this is the log base 6 of x plus the log base 6 of y. So that's expanding this using the product property. Expand this one using the product property. This is the natural log of 4 plus the natural log of x. Quotient. The quotient deals with a subtraction. So this is the log of 9 minus the log of x. The next one, this is a quotient. So it's the log base 7 of z minus the log base 7 of 4. The power property says that the log base b of m to the n is n times the log base b of m. You can bring that exponent out in front of the logarithm. So what this means is this is x times the log base 5 of 4. And this one, this is 4 times the natural log of x. So I've got the product property, the quotient property, and the power property. Now, what gets a little confusing is we throw them all together sometimes, okay? Let's use all 3 of these rules to expand these logarithm expressions. So it may help to write this one as the log of x to the 1/3 power. That's what it means to take the cube root. Now to expand this and have no exponents in my answers, I can use the the power property, which tells me that the log base b of m to the n is just n times the log base b of m. So that means bring this exponent out front. This is 1/3 log of x. In the next one, I've got powers and I've got quotients, okay? So if I use the quotient rule, I get that this is the log base 4 of x to the 4th minus the log base 4 of 7, okay? To simplify it completely, now I'm going to use the power rule and write this as 4 log base 4 of x minus log base 4 of 7. Let's look at the next one. So this is going to be using, if I use the product rule, this is the log base 8 of x to the 7th plus the log base 8 of y to the negative 4. And then if I use the power rule, it lets me bring that exponent out front, 7 times the log base 8 of x minus 4 log base 8 of y. All I did was bring the exponent, the 7 and the negative 4, out front. The next one is a natural log. So let's use the quotient rule. So I start out with the quotient rule, and that gives me the natural log of 3x squared minus the natural log of 2y. Now I'm going to need to use the product rule right here. This is the natural log of 3 plus the natural log of x squared. And then the next one, this is the natural log of 2 plus the natural log of y. I'm almost there. I'm going to have to use the power rule right here. So this is going to be the natural log of 3 plus 2 natural log of x minus natural log of 2 minus natural log of y. So that one had a lot in it. It had the quotient rule, the product rule, and the power rule to get this one all expanded, okay? Let's look at the next one. When you see a radical here, it helps to write this as the log base 4 of 4x to the 1/2, okay? Now, if I use the power rule, this is 1/2 times the log base 4 of 4x. Now I can use the product rule on this log of 4x. So this is going to be 1/2, and then I can write this as the log base 4 of 4 plus the log base 4 of x. I'm probably going to take that as an answer, but if you're thinking about this, log base 4 of 4, what is that? That means that 4 to the x is equal to 4. This is just 1. So this can be written as 1/2 1 plus log 4 of x. Okay, so I'm probably going to take either of those as an answer here. Natural log of e to the 6 minus 7. So using the quotient rule, this is the natural log of e to the 6 minus the natural log of 7. This is the log base e of e to the 6 minus the natural log of 7. Remember, log base e of e to the 6. That is just 6. Okay, 6 minus the natural log of 7. Okay, so those are rules that really need to get into your muscle memory. Let's just do a few more while I've got time here, and I've got you. Using properties of logarithm. Remember, there are 3 properties that we have. We have the product, we have the quotient, and we have the power rule. What this means is the product rule. The log any base of mn, that's the log of m plus the log of n. That's the product rule. The quotient rule says the log base b of m over n is the log base b of m minus log b of n. And then the power rule was the log base b of m to the n is n times the log base b of m. You bring that exponent out front. So let's look at some examples here again. So this is going to be the log base 6 of 4x minus the log base 6 of 3y. Now I can use the product rule. That was the quotient rule. This is the log base 6 of 4 plus the log base 6 of x minus, okay, what is this one? This is the log base 6 of 3 plus the log base 6 of y. This final answer, log 6 of 4 plus log 6 of x minus log 6 of 3 minus log 6 of y. You have to be very careful with this minus sign here. Remember that minus sign distributes into both of those terms. Looking at the next one, start out with a quotient. This is the log of ABC minus the log of D. Now let's use the product rule. This is the log of A plus the log of B plus the log of C minus the log of D. Looking at the next one, this is the log of x cubed times y to the 1/3. And that is not added, that is a multiplication. So I'm going to use the product rule. This is the log of x cubed plus the log of y to the 1/3. Now you use the power rule. This is 3 log of x plus 1/3 log of y. Number 4, start out by using the quotient rule. This is the natural log of 4n cubed minus the natural log of m cubed r to the 4th. Now we're going to use the product rule. This is the natural log of 4 plus the natural log of n cubed minus, this is, use the product rule again, natural log of m cubed plus natural log of r to the 4th. Now I've got the natural log of 4 plus natural log of n cubed minus natural log of m cubed minus natural log of r to the 4th. Now I use the power rule. So this is natural log of 4 plus 3 natural log of n minus 3 natural log of m minus 4 natural log of r. So it's just using these rules repetitively to break these things up and to work from there. So that should be it. You should be able now to work on the homework. Just take your time with this. And again, you've got product rule, quotient rule, power rule, knowing when these things apply, okay? So one of the things that people make mistake, if I had something like the log of, 4x cubed, well, I can't use the power rule right away because the only thing being cubed is the x. So you have to use the product rule first. Then you use the power rule. Log base 4 plus 3 log base x. Now that would be different than if you had the log of 4x cubed. Then you would start with the power rule. That 3 times the log of 4x, and then this would be 3 times the log of 4 plus the log of x. Then you would use the power rule, the product rule after the power rule. So just keeping in mind your algebraic manipulation as you go through these.